Hello and welcome to the successful collaboration between the Army and a university Center for Advanced Electro-Photonics with 2D Materials webinar. This webinar event is hosted by the Army HBCU-MI Student Program for Army Research and Knowledge, known as SPARK. Today's webinar focuses on the power of collaboration between the Army and academia to advance both science and national defense. We are pleased to welcome today's distinguished speakers, Dr. Ramesh Budani, a professor at Morgan State University, Dr. Susanna Tone, a professor at Johns Hopkins University, and Dr. Owen Vail, physicist with the Photonics, Electronics, and Quantum Sciences program at the Army Research Laboratory, Adelphi Laboratory Center. Together, they will showcase how the Center of Excellence for Advanced Electro-Photonics with 2D materials is driving innovation at the intersection of cutting-edge science and national security. Their discussion will highlight how 2D and van der Waals materials are enabling breakthrough technologies such as wearable solar cells, quantum emitters, spin-based devices, and thermoelectrics. This collaboration also highlights the role of the Department of Defense outreach programs in expanding research opportunities, strengthening workforce development, and fostering entrepreneurial pathways for students, faculty, and Army researchers. It is an excellent example of how joint innovation enhances STEM education while advancing Army capabilities. By the end of today's session, you will gain a deeper understanding of how Army academic partnerships are shaping the future of quantum-enhanced electrophotonic technologies and creating opportunities for the next generation of scientific leaders. My name is Crystal Nolan. And before we begin, I'd like to let you know that at any time, you can place questions in the Q&A feature of Zoom. Our presenters will address them during the Q&A session at the end of the presentation. If you have any questions about using the Zoom platform during this event, please feel free to enter them in the chat window now. Technical support is on hand to help with any issues you may encounter. And finally, within the next few weeks, we will send a link to the webinar recording for anyone who has registered for the event. This will allow you to revisit key parts of the presentation and the Q&A, or share the session with colleagues who may also find it valuable. And with that, I'm going to turn it over to Dr. Vail.
Great, thank you for the introduction. Let me just pull up the PowerPoint. That working?
Yes, it looks fantastic.
Still good? Okay. All right. So my name is Owen Vale. So I'll be talking to you about the center and the Army Research Lab and the role that we play. Hopefully, this also helps you kind of connect with the broader ecosystem, right? So I'm a physicist at the Army Research Lab in Adelphi, Maryland. This is the Adelphi Lab Center. I'm also a cooperative agreement manager for the Morgan State Center of Excellence. This is funded by the Office of the Undersecretary of Defense. So U.S. Department of Defense, right? The U.S. Army. Then in the U.S. Army, we used to be the Army Futures Command. Now we're moving towards the Training and Doctrine Command. But anyway, under that is DevCom Army Research Lab. Within the Army Research Lab, we're in the Army Research Directorate, which is the intramural thing. It's Army scientists actually working on and solving scientific problems. Then within that, we used to be the PECs, which is Photonics, Electronics, and Quantum Sciences, which was what we introduced as. But we're moving into Advanced Photonics and Electronics, APE. So within the Advanced Photonics and Electronics division, I'm in the Advanced Electronics branch. And then within that, I'm the Physics and Optoelectronics at Low Dimensions Fold team, right? So hopefully this gives you some perspective on kind of where I'm situated, how big the national organization is, and some of what we're interested in, right? We're interested in photonics, electronics, low dimensions, optoelectronics, physics, things like that. I grew up in Massachusetts. I did my graduate career at Georgia Tech. And then I came here. It was kind of interesting. We connected my professor and the government person that I connected with, Patrick Folks. They worked together at a national laboratory in Tallahassee, right? So they knew each other through the scientific community. So these connections between academia and government are longstanding and can really help propel careers forward. And that's kind of what I'm going to be talking about here, right? So these are the things that we have and what we're looking for. So we're able to do fabrication, thin film and 2D materials. We have a really nice clean room. We can do, your etching, metallization, e-beam lithography. We also have laser lithography and ability to make masks and things like that. We recently built this stacking station here. Am I able to use my mouse pointer at all? I guess not. But the stacking station on the right there, on the top right, is a new capability that allows us to assemble these 2D materials. You have the probe station in the middle on the which the top middle, which is where my student, where a lot of students have been doing measurements of these materials, right? So electronics and optics measurement is something that we are capable of doing. We do a lot of these devices in the bottom left, like Hall bars. Where you send current and you measure voltages and things like that. We're also able to do full-on optical experiments, like in the bottom right. This is a second harmonic generation experiment where you send in light at different polarizations and you get reflection or transmission. And then also optoelectronics measurements, like the one in the middle there, where the light comes in into the sample, and then you use electrical probes to take electricity out. So light in and electricity out. And then my kind of bread and butter are these high field magnetotransport type measurements. That big cryostat on the bottom on the left there is a 18 Tesla 2 Kelvin magnet with a dual axis rotator, which really allows us to probe the full electronic space of these materials and kind of understand what fundamentally is happening. And to design devices and try to transition these technologies, right? So we have a lot of experience with government. We are the government, right? But the government is a large organization. There's a lot of different ways to connect. There's a lot of different opportunities, funding, career. There's a lot of things that you can get out of working with the government. And so a lot of it is hard to navigate. It's a lot easier if you know someone who understands or who knows the paperwork or who can connect you with the right person, right? And then more than that is Army priorities. These are the things that we are interested in researching and focusing on going forward. We have a lot of that. ARO is the Army Research Office. We're the Army Research Directorate. So we're the intramural, and the ARO is the extramural. So they're externally facing and they will fund academia. So you might go to ARO to try to get funding as an academic professor, and they will try to fund things that are Army priorities. Now, we also on the internal side are trying to study things that are Army priorities. So we have a pretty good purview into what they might be interested in funding. So working with us simultaneously helps you with the explicit things that we have to offer, but also helps you understand kind of where the national perspective is driving towards, so that you can kind of hop on that boat, right? What we're looking for is we're looking for new, cool physics, materials, designs, techniques, devices, right? So the types of materials that you're working with, quantum materials or semiconductors or what you're working on, the different type of techniques that you bring to the table, new weird things that we haven't seen before, the device design, right? Like not only the devices themselves, but also the concepts of where you're trying to go, what kinds of responses you're trying to get out of these devices. We are trying to transition technologies. So if you are a company, or if you have a collaboration with a company or a small business, something like that, or if you have this idea of this, you more than an idea, you have a technology that's been proven, but you don't know how to get it to the next step, that might be something where we can engage with you. And then ultimately people, right? Workforce development. We want to bring in students. We want to bring in post grads and help them connect with a long-term career in STEM. We also want to increase just general national STEM investment, and help students kind of connect with the defense priorities. So speaking of student connections, these are some different programs that we have. I really can't recommend enough the OUSD HBCU-MI summer internship. This is a full-time internship. It's got the most pay. It's like 1,200 or 1,400 per week. The housing is included, so they will position you right next to the lab, and you're in here every day, and you're learning all sorts of things, and you're getting paid a good amount. And the best part is that it doesn't cost us anything, so you're really able to connect with the best people because there's not a concern for where the funding comes from. AEOP, which is the Army Educational Outreach Program, this one is extremely flexible. It does require internal funding. So this is more of one where like we'll connect you with something if it matches our priorities. There's a lot of other programs. There's Spark, which is the one that put on this this event. The outreach office can help you connect with the right program. We also have the center, right? The Center of Excellence. And this is where the Center of Excellence starts to come in with poster sessions and meetings. These are quasi-formal exposure to scientists. And it's a chance for them to present to us and to present to a third party in general, someone who might have a different perspective, who can help ask them questions and reassess what they're working on. We want to build these personal relationships. The professors suggest students to connect with, but also through research collaborations. Like I'm working on something, you're working on something, we want to work together, and your student happens to be working on that thing. So I will end up interacting with that student directly, and that will build the personal relationship. So not only through suggested connections, but also through kind of coincidence and happenstance. So the students that we've connected with, these are ones that we've brought into the lab or are going to bring into the lab. Stanley McCombs at XPS, Mia and Maya Merritt were two sisters that worked on very different things with different groups, RF inductive responses versus photoluminescence mapping in silicon carbide. Ayana Spate was here this summer, did current injection in quantum channels. Vaughn Kamal did nonlinear Hall effect this summer and is continuing through the year. Hunter Saylor, and all of those ones were all Morgan State. Hunter Saylor and Madeline Marlin are new Johns Hopkins graduate students that I'm hoping will be, or not just hoping, but we are bringing in for this year in 2D stacking and modeling. On the right are some different pictures from some of the things we've been working on with XPS and the contact resistance. No two of these projects or people are the same. Even the twins are nowhere near the same. They each come with their own challenges and skills. Our interaction has to be tailored to each student, but the programs that we're putting them into are kind of one size fits all. They're supposed to just be very generic. Everybody can kind of go through the same process. So there's this balance between guidance and freedom. We want to tailor the contract and the program and the interactions to the student, but we also want to allow the student to kind of freely interact with the government and get out of it what they can without limiting them to which kind of research they're allowed to do or work with. But we still want them working on Army priorities. So there's a nice little balance there. So these are some vignettes of different programs that we worked on. So this is topological RF, which is high frequency quantum topological channels. So we have these probe stations with ground signal ground probes. The students fabricate this whole device in the clean room off of a quantum material. Then we put down the probes in the probe station. We get out these Smith charts for multiple different samples. We try to do like a design where we try to model and simulate the circuit, and then match our simulation to the experiment. And this was a number of different students that worked on this, and it's something that we're hoping to push forward, and we're hoping to get into the space where we're really like modeling and simulating new novel capabilities that can't be done in normal semiconducting materials. Then pushing forward, the nonlinear Hall effect. So this is an effect for passive nonlinear elements, reduced size, weight, and power for fundamental circuit elements, AC to DC full wave rectification. So we go from these like diode bridges like you see in the bottom left to a very basic just Hall bar. So this is very deep. They have very deep from a physics perspective. You could talk about quantum gravity and the Berry curvature dipole and all of these really deep physics questions. But there's also very applicable concepts, right? Like tunable broadband responses from DC to IR, agile frequency response with harmonics and quantum materials. These are physical uses and applications for these materials, but they have a lot of depth from a physics perspective. So you can kind of approach it from a lot of different levels. And this is really useful for students because you don't really know where they're coming in, and kind of getting them situated and connected with a program means meeting them at their level a little bit. So having a program which really can span the levels from very high level physics to very applicable experimentation. So here we measure the second harmonic response as a function of input current, and we get this nice quadratic. So the actual measurement is also pretty straightforward, but there's a lot of data. It's a very big multidimensional space, data space, and so having a student kind of build intuition and work with this for a while, it can help a lot. I don't necessarily have all the time in the world to be down in the lab doing these experiments. I try to spend a lot of time in the lab. You do get a lot of time as a government employee in the lab, but there also is a lot of other things that you have to worry about. So bringing in these students, having them work on these kinds of experiments has been really, really useful for us. So the spaces that I'm interested in, I'm continuing U.S. dominance in advanced electronics to prevent technological surprise by harnessing electronic materials. So there's a lot of different electronic materials that we're interested in, but semi-metals are kind of one of the places that I highlight. These quantum materials, which include collective behaviors, quantum phase or confinement, dimensionality, geometry, topology, symmetry is a big one. Particularly, I focus on quantum channels. So topological insulators and 2D materials are kind of my bread and butter. But there's a lot of different technology spaces in the Army, in the Army Research Lab even. I have a lot of coworkers here that work on all sorts of different material systems, different technologies, and so on. So please connect with people and find out what they're interested in. So beyond internships, right, we're meeting monthly with the Center of Excellence. This provides us regular points of contact, and the Dr. Budani and Dr. Tan will express these a bit more, how the center like exists. But from my perspective, it provides me an opportunity to invite other personnel to come see what the center is working on. It's a chance to comment on the work and kind of drive the future. And sometimes the students that I work with are directly presenting in these things. So it's an opportunity for them to kind of present in a low stress environment. Sharing research. We are happy to share materials, devices, samples with academic collaborators. And we're also happy to just talk about techniques or approaches, what things are interesting to you, how do you do them, how do we do them, and maybe how to connect on those things and build collaborations. We're also participating in the center priorities. So we've directly done some XPS on Center of Excellence materials. We're trying to make some joint publications between the groups. So these are very concrete kind of achievements of collaboration. We also have a big clean room. I mentioned that a few times. So Johns Hopkins and APL are in the clean room a lot, working on their own stuff, but also working on center stuff. So I'm able to have a lot of discussions in the corridors of the lab, which has been really, really helpful. And then just connecting with these graduate students, right? Connecting them with opportunities during their career, during their graduate career, but also post-graduation. There's a lot of programs and things that try to help STEM students get into government labs. Two really important ones for me are the SMART program and the NDSEG program. Both of these programs pay your tuition while you're a graduate student. But the SMART program will align you with a job after the PhD. So we'll connect with you, and the student will be obligated to work with us for the same amount of time that we pay their tuition. So this is really great because the student has no question about what they're going to do after graduation. They're going to go work with us. And it's usually beneficial to everyone all around. The NDSEG is the other end of the scale there, where they'll pay their tuition, but there's no obligation to come to work afterward. So you know, there's a lot of different ways to connect. We're very excited to work with you all, and we're happy to connect on really any level. Students are very, very awesome. But there's also a lot of research connection and collaboration that we can work with you on, or even just discussing with us about priorities, what the Army is interested in, and where we can go from here as a nation. From there, I'm going to pass this over to Dr. Budani.
Good afternoon, everyone. Once again, I am Ramesh Budani, the director of the DoD Center of Excellence here at Morgan State. Our center is located on this lovely and historic campus of the university. Most of the research is done on this building here you see. Oh, I think I can't. Anyway, on the left corner, the Dixon Research Center, which is a part of the School of Computer, Mathematics, and Natural Sciences. A key mandate of the school is to train underrepresented and underprivileged students in STEM education, and we all are dedicated to do that. I joined Morgan State in 2018, and my objective at that time was to train undergraduate and graduate students in advanced materials technologies and material science. To do that, it was necessary to have a well-funded center with partnership with physicists, chemists, material scientists, and engineers. And that opportunity came with this announcement from the DoD. It asked for creation of a center of excellence in partnership with nearby institutions as well as DoD labs. So we started looking for a partner, and we did not have to go very far, only 10 minutes to drive from here, Johns Hopkins. And I talked to Dr. K.T. Ramesh, who is the director of HBCU-MI at Hopkins. He introduced me to Dr. Sujana Thorn, and then we also had the privilege of working with Paulette Clancy and Dr. Seifu from Morgan State, 4 of us. We sat together and wrote a proposal for the creation of the center. We submitted the proposal just a day before the deadline. That was April 30th, 2021. And lo and behold, after 3.5 months, we got a great news that the center has been approved, and the award letter you can see at the bottom here. We had a formal kickoff of the center on 27th of October. Those were the high days of COVID. So as you can see in the middle, our president, our VP research, and our provost, everybody is wearing a face mask. This meeting was also attended remotely by Honorable Heidi Shue, the Undersecretary of Defense, as well as the Director of ARL Adelphi, Provost GHU, and Ms. Evelyn Kent, the Director HBCU-MI and Outreach at DoD, the Office of this Undersecretary. So this is our team, starting from the top. That's me. I'm going clockwise. We have Dhiraj Seifu, Birol Osterg, Yuchan Lan, Alex Samakolov, Ijana Nagusi. So we are all from Morgan State. And then we have Natalia Disco, Rama Venkat Subramaniam, Peter Armitage, David Schickenhammer, Paulette Clancy, and Sujana Thorne from Johns Hopkins and APL Johns Hopkins. Paulette, Sujana, and Dirje are also the co-PIs of the center. Our cooperative agreement manager at the moment is Dr. Owen Vale. You heard him just before me. And earlier, our camps were Dr. Jennifer Satin and Dr. Frank Gardia from ARL. So the primary objective of the center is to mentor and train underrepresented students in STEM. We have three specific goals. The first is to develop skilled workforce in the areas of critical materials and technologies. Second, make champions of advanced research on electrophotonics using 2D semiconductors. And third, nurture leaders for creating new defense technologies. Now the center takes input from 4 different channels. We start very young with high school summer interns. Then we have our own undergraduate UG STEM students from our school, as well as from the engineering school. And then the 2-year MS program of Morgan State, and the newly launched PhD program in advanced materials, which is run jointly by physics and chemistry here at Morgan State. The ultimate goal is to produce skilled scientists and technical force to serve defense R&D and defense industry. Now, as I said before, training is a key component of the center. So we have very close cooperation between Morgan, Hopkins, and DoD labs. Morgan has enough funding to support 10 undergraduates and 6 graduate students, whereas Hopkins can support 4 undergrad and 5 graduates. These students work very closely and they get training at the DoD labs. As you will see pictured down here, we have 7 students who have been trained by Dr. Vale at ARL at Delphi. And the last 2 students, Paul and Abhishek, are working very closely with ARL Aberdeen scientists. The cooperation, again, is very important, and that we ensure by having these monthly meetings. We meet every second Monday of the month from 12 noon to 2 p.m. And we ask our students, our postdocs, even faculty to make presentations of their recent work. So I'm showing you the agenda of this month's meeting, which was held on September 8th. And we had 3 speakers from Morgan State and 3 from Johns Hopkins. So this is a very important platform to discuss the recent scientific advances, our difficulties, how to work closely together. And the participation is usually 35 to 40 people attend this meeting. This is our flagship program, the high school summer internship. We take students in the summer for 5 weeks. They usually come second day of day after Independence Day on July the 5th and work with us for 5 weeks, 6 hours a day, 30 hours per week. And these we make this flyer, and this flyer and the relevant literature about the program is sent to all high school principals in the city of Baltimore. And they recommend students. The response is really overwhelming, and we pick up 5 or 10 best students and give them the opportunity to work with us here in the lab. So for example, this is the program of year 2023, and we start by the first day is the induction ceremony. We call it lab coat ceremony. We tell them about the safety protocols, ask them about their research interests, and then at the end of the program, we have a closing day when each student is asked to make 15 to 20 minutes presentation of his or her work. They also make a poster presentation, and they also submit a written report. All these reports are compiled and submitted to DoD as part of our annual report. So this is this year's summer program. Again, this time we had 5 students. Induction day, and the graduation day. And here you see one of our postdocs, Ravi, explaining them how a helium liquefier works, how a superconducting magnet works. So all these facilities are in the lab, and student, postdoc, graduate student interaction is very important. And in the bottom picture, you see another postdoc, Rajiv, is explaining the workings of a USB sputtering machine. We work very closely with our undergrads in the labs. And here are some pictures, some examples. On the top left, you see my colleague, Dr. Osterk, working with his students, explaining them low temperature photoluminescence measurements. On the right corner, you have Dr. Seifu working with his undergrads, explaining them how a sputtering machine works. In the middle, you have Maya Merritt. She's preparing a sample for transmission electron microscopy. Just below her picture is Kigozi. He's exfoliating molybdenum diselenide crystals, preparing an exfoliated ink so that we can make films. And then on the right, on the left corner, you have Sam explaining to his graduate students how this state-of-the-art Raman spectrometer works. And again, on the right corner, you have the sputtering machine. Students are interacting with the postdoc. So far, we have graduated 15 students, 15 undergraduates have graduated from the center, and most of them have gone to graduate schools in and around greater Baltimore, DC area, but 2 of them have decided to become high school physics teachers. That's also good. And 2 of them have come back to us, and they are working for their PhD in our program. This year, at the moment, we have 6 undergrads working in the labs. We would like to fill 4 more, which will be done this fall and early spring. We have a large number of graduate students now. As you can see here, we have 9 graduate students. And this has happened because we have our own PhD program now in advanced materials. So all these students are registered in that program. The pillars of the lab or the center here at Morgan are these 3 postdocs, Ravi Basnet, Tamal Dalu, and Shubha Chatterjee. They work very hard helping undergrad and graduate students in running various facilities, in telling them how to write papers, how to make presentations. So their presence is really very important. So we have graduated 6 master's students so far, and 3 PhDs. And all three PhDs graduated last year. And the master's students, one is this year and rest graduated last year and the year before. So it is really helping in training students in the area of advanced material science. We encourage our students to participate in national and local conferences. This gives them exposure to make presentations, interact with various other scientists. So here is one picture. 6 of our students went to make poster presentations on 10th and 11th of July in Arlington. This meeting was organized by DoD. And Dr. Vail, you can see there, he's appreciating some of the posters. And the titles of the posters are listed down here. Now, coming back to research, the second main objective is to explore the frontiers of 2D physics and technology. So we are working on materials. First are these layered semiconductors like tungsten diselenide, tungsten disulfide, and their doped versions with 3D transition metals and 4F electrons to tune their thermoelectric as well as photoluminescent properties. We also work on van der Waals topological insulators like bismuth telluride, antimony telluride, 2-dimensional ferroelectrics, CIPS and CCPS, and 2-dimensional ferromagnets like Fe5, germanium, tellurium 2. We use a variety of techniques to grow these materials here at Morgan State. So atmospheric pressure chemical vapor deposition is one of them. Then we have pulse laser ablation, sputtering, MOCVD, and single crystal growth with chemical vapor transport. Now, these are the areas of research which are being pursued jointly with our colleagues at Hopkins. So first is wearable solar photovoltaics. The second one is photodetectors and light sensors. The third one is quantum transport, quantum Hall effect, anomalous quantum Hall effect, and things like that in various heterostructures. Quantum defects in semiconductors, addressing them with microwave modulated photoluminescence measurements, thermoelectric refrigeration and optimization of the figure of merit, ZT, electronic structure calculations, and 2D ferroelectrics. We are addressing fundamentals and trying to make some photonic devices. So here are a few examples. So this is a piece of work that we completed last year. We were able to make high quality thin film thermoelectric devices. These consist of P-type material is antimony telluride, N-type is bismuth telluride or bismuth 85 antimony 15. These materials, thin films, were made using pulse laser deposition as well as magnetron sputtering. So we characterize their thermoelectric response using lasers. And this work came out last year, published in Applied Physics Letters. This is the second piece of work done jointly with Dr. Thorn's group at Johns Hopkins. This is low temperature growth of wafer scale WS2 films. So we made phototransistors, measured the response of phototransistors as a function of laser wavelength, laser intensity, gate voltage, and temperature. And this work came out this year as a publication in Journal of Applied Physics, and Morgan State is filing a patent on this process of large-scale growth. The third one is phototransistors made of vanadium-doped tungsten diselenide. These samples were also made at Morgan State. The doping was done with a combination of thermal evaporation, PLD, and sputtering. And you see the device structure in the middle, a channel length of about 40 microns. Again, we characterize the phototransistors, but it was very important to see where the vanadium dopant is. And for that, our collaboration with ARL Aberdeen was very, very useful. We used Rutherford backscattering to characterize the presence of vanadium. And we also use X-ray photoelectron spectroscopy, as well as SEM and AFM. So this work came out last month as in Applied Physics Letters, and we are also in the process of filing a patent on this process. Now, collaboration with the Army laboratories is very important for us because we don't have many state-of-the-art facilities here, and also the scientific interaction has much more value. So we work with ARL Adelphi, with Dr. Vale, and with Dr. Ibrahim Bulares in the areas of X-ray photoelectron spectroscopy, electron beam lithography, photoluminescence, and device characterization in the probe station. We are also working very closely with ARL Aberdeen in the areas of Rutherford backscattering, X-ray photoelectron spectroscopy, atomic force microscopy, SEM, and transmission electron microscopy. Our collaborators there are John DeMare, Thomas Parker, Anjana Asthana, Cameron Schock, and Shashi Karma. This collaboration is also very, very fruitful. Now we are running phase 2 of the center, and the priority of phase 2 is to further strengthen our collaboration with the Army labs. So new materials that we are going to explore are 2D ferroelectrics. These will be in the form of thin films and single crystals. Doped transition metal dichalcogenides. We are trying to make optically active semiconductors as well as thermoelectrics. 2D ferromagnets. And all these will be made by different processes, which I described earlier. Advanced structural characterization and measurements of properties is important. So for that, the collaboration with Army labs in the areas of Rutherford backscattering, X-ray photoelectron spectroscopy, high-resolution transmission electron microscopy, electron beam and laser lithography, and pump probe measurements of photoluminescence and photoconductivity are important. We would also like to prepare some prototype devices. And in that, we have photosensors, photovoltaic devices, as well as ferroelectric solar cells, as well, and thin film thermoelectrics for cooling and sensing applications. So with that, I would like to thank you all for listening to this presentation. And on the top, you see the logo of our center. And I would like to express my profound gratitude to the Department of Defense for supporting this center. I would also like to thank the chairs of physics and chemistry departments here at Morgan State, the dean of our school, the office of the provost, the VP research, and the president for their continued support to the center. Thanks to our collaborators from GHU and ARL for being such wonderful colleagues, and to our cooperative agreement managers, Dr. Vail and Dr. Gardia. Lastly, I would like to thank Ms. Evelyn Kent, for the director HBCU-MI and outreach at DoD, for visiting Morgan State several times and for encouraging our students. If you need more information about the center, please contact Ms. Tori Holland. She's our very efficient administrative assistant. Her phone number, email, and our website links are given below. Thank you. So now,
Thank you, Dr. Ramesh.
Yeah.
Susanna, if you can take over from here.
Absolutely. So good. Hopefully you can see my screen. So I'm cognizant that we're running out of time here, so I'll try to keep this a bit short, but I did want to give some perspective from sort of the Johns Hopkins side of this collaboration on, how to work both with the Army labs and, our excellent partners and neighbors down the street, Morgan State University. So the first thing I want to talk about is, forming the collaboration. So how Ramesh described how Johns Hopkins got involved. But, I want to emphasize that really what was important was that we had this complementary expertise. And, I think it's important when thinking about writing any big proposal, but especially when, thinking about doing this sort of directed research that's meant to align with DoD priorities, that you're building the right team. And for us, that meant looking at what, there was expertise in. So both at Morgan State, who were the leaders of this collaboration, and then what we could bring to the table. And so, this is an oversimplification, but I think one thing that Morgan State is really strong in, led by Dr. Badati's team, is advanced materials growth. They, of course, do characterization as well. And what we were looking to bring to the table, and what Ramesh was looking for when he came to another center at Hopkins we were affiliated with, was sort of the device side of things. And so, my group has traditional expertise in developing new kinds of devices based on nanomaterials. And so that was sort of aligned with this idea that the physicists and chemists at Morgan State were growing these new advanced materials. What we also recruited Paulette Clancy to the team, as Ramesh described, who's an expert in molecular simulations and modeling, so specifically in density functional theory, molecular dynamics, and related techniques. And then we were also able to bring in some of our colleagues from the Johns Hopkins Applied Physics Lab. So JHU APL is actually a UARC, which is a University Affiliated Research Center. It's actually the largest UARC in the country. And our colleagues that we recruited to join the team from APL also have appointments as professors at Johns Hopkins. So there are, Johns Hopkins colleagues as well. And they brought some, excellent expertise, as well as sort of characterization equipment and things like optics, thermoelectrics, and the knowledge on how to scale up and transition some of these technologies, which Dr. Vail mentioned as being an important and critical component that's of interest to the DoD. And then, of course, there's the Army Research Lab, which we were very fortunate to partner with on all of this work. And, in addition to, of course, the detailed application knowledge that they bring, as has already been described, they offer all kinds of advanced characterization techniques and knowledge and opportunities for our students to really learn some things that they wouldn't otherwise have access to. And so then just briefly, sort of Ramesh described the faculty that are involved in the center. So here are the 4 initial participants from the Hopkins side: myself, Paulette Clancy, Rama Venkatesubramanian, and David Treckenhammer. And so, we were really, really fortunate to be able to build connections with, some of the founding Morgan State faculty in this center, which are listed here. And so I just want to sort of show the web of connections that was developed explicitly through this center. And of course, there's other connections that were pre-existing between the Hopkins faculty and between the Morgan State faculty. But the point is that these are the connections that were newly enabled by the center's existence. And then for phase 2, we pulled in Peter Armitage and Natalia Drishko, also from JHU, and we're able to build more connections there. And these are sort of direct collaborations, co-advising of students, co-publishing, and sharing of materials and ideas. So I do want to say a couple words on how we actually wrote the initial proposal that funded the center. And really, obviously, writing the proposal was a team effort. And we were fortunate to have a strong leader in Professor Budani, who pulled us all together and, smartly sort of assigned sections to each contributor as we were thinking about the research effort, but, emphasize the need to discuss collaborations early and often. And so essentially every one of the sort of sub-projects that we proposed were collaborative efforts. So none of them were sort of single PI kind of efforts. The point was if, the actual research had to justify the existence of this center. Like, why do we need a center to do this research? And the reason is because none of these, individual research projects could be done without the joint and combined expertise that our team brought. We also were very deliberative about reaching out to ARL scientist stakeholders in the beginning of the proposal writing process to make sure that we both had alignment and co-interest and ways to collaborate with them as well through this process. And the second part of the proposal is really all about the workforce development, as Dr. Budani described. And so we integrated students into every aspect of the research plan. We were very deliberative about our mentoring plans, implementing a team mentoring concept. And of course, a big aim was to be able to develop and grow new programs to bring in more students. And so Dr. Budani gave the example of the high school programs that we developed there. Okay, so just like Dr. Budani showed for the Morgan State students, we've graduated many excellent Hopkins students now who've been involved in the center. So here's sort of a summary. And I also am including, I won't go through each one, but I'm including their project themes just to give you a taste of all the different things our students were working on, as well as their current affiliations. And I think what you'll notice is that most of them do end up going and becoming part of the defense workforce in one form or another. So we've had the students go to, defense contractors like Northrop Grumman or Applied Physics Lab, so the UARC that I mentioned, as well as, other sort of affiliated companies like the DoD Biotechnology, HPC Software Applications Institute, NIST, other government labs, and then, of course, we had some master's students go on to do PhD programs as well. So, really the students we graduate from the center, they are joining that, advanced STEM workforce. Here's some current students and postdocs, graduate students and postdocs that we have involved from Hopkins in the center. And again, a lot of these students have had direct opportunities to engage with ARL, whether that be through internships in the case of Hunter Saylor on the right, or Serene Kamal has been trained in techniques like XPS at ARL Adelphi. And then we've had many undergrads involved in the center too, and the story is much the same there. So a lot of our undergraduates do end up going on to graduate school or otherwise sort of, relevant industries. And then we have a bunch of current undergraduates as well, all of whom are excited to be engaged with the center. And I really think things like these monthly meetings enhance the educational opportunities that they're getting in their programs. We also at Hopkins utilize the Army Educational Outreach Program to host interns every summer. And so here are 4 of the interns that we've hosted. I will mention that one of our interns from last summer, 2024, is a current SMART Scholar. So again, another program that was mentioned that our students are taking advantage of. But all, except for the one that's still in high school, are gone on to major in STEM fields in their undergraduate programs. So a little more about program building. I think, we were in the beginning of the program, one thing that we did was we organized joint visits and tours of all the program facilities. So the Morgan State and ARL team visited Hopkins. We all visited Morgan State. And then we also had the opportunity to tour both ARL Adelphi and ARL Aberdeen, just to get a joint sense of all the different facilities and capabilities that the different partners sort of brought to this effort. And then we sort of maintain these connections with our regular monthly meetings, which always involve student presentations. So Dr. Budani organizes an excellent agenda that is, almost all student presentations. So students are given that chance for professional development to present to this external audience every month. And then we also have yearly workshops where people more formally present results and engage. And then our senior students, of course, have mentoring opportunities. And all of the graduate students that have been involved on the Hopkins side are mentoring undergraduates and high school students throughout the program. So I'll just say a couple words about some research results because I do want to leave time for questions. But, my group has had some, great opportunities to work together. So I have pictures of all the students involved in these projects on these slides, to do things like design new plasmonic enhancement strategies for 2D material photodetectors. And this effort very heavily utilized the clean room at ARL that was referred to. And doing other kinds of things. This is actually a project led by an undergrad, Eakin, who's now at Stanford, where he was able to sort of use all kinds of different optical enhancement concepts to achieve near perfect absorbance in monolayer or few layer 2D materials, which is quite a feat. And then we've also integrated 2D materials into solar cells, and had both graduate students and undergraduates heavily involved in this program. This was a collaboration with Yu-Chen Lung at Morgan State as well. So, as Dr. Budani mentioned, we were able to proceed with the center renewal, and what we really did there was build on our early successes to expand the scope and evolve the center theme to focus on sort of new ferroelectric and quantum applications of 2D materials, as well as more traditional electro-optics and photonics. And so, Dr. Budani already introduced some of the advanced technologies and themes from the center renewal. And one thing we also did was we pulled in two physicists from Johns Hopkins, so Natalia Drishko and Peter Armitage, who are shown here, to add their expertise in things like low temperature condensed matter physics and Raman spectroscopy, as well as terahertz spectroscopy and quantum magnetism. So just to conclude here, I want to talk about the fact that we've really been able to have some, I think, see some lasting impacts, primarily on our students and on the connections that have been built between these researchers that we expect to outlive the actual funded life of this center. And so one is that, students are going to be given all these opportunities to interact with the ARL scientists through monthly meetings and workshops, as well as sort of more informal equipment training, scientific collaborations, of course, as well as more formal internships at ARL. And that's been really helpful for their careers going forward. And then, of course, we've built on the center to essentially form more connections between Morgan State and Johns Hopkins, as well as ARL, through things like, joint proposals and projects. So an example I can give is that, based on the connections we have made through this center, we actually had an NSF NRT funded, there's a typo here, sorry, it's NSF, which is a graduate training program that is joint between Morgan State and Hopkins in advanced microelectronics. We do joint student advising and, really feel like we've, through all these student-centered programs, developed this new workforce pipeline for, the DoD in general. Okay, so that's all I have. And so I think I will then stop my share so we can proceed to the questions portion.
Okay, thank you so much, Dr. Tone, Dr. Budani, and Dr. Vail for your very comprehensive presentations. We do have some questions from the attendees. The first question is, will there be another open funding call for centers of excellence between HBCU-MIs and the DoD to do these collaborations?
So I think there's regular calls for these centers of excellence. I'm not totally, I didn't respond to the call, right? So maybe Dr. Budani can respond to that, but I think there are kind of regular, the national structure of HBCU-MI things, these fall under Evelyn Kent, and she has done an excellent job to defend the program and to keep it going. So I do think that it's going to keep going, and there's going to be new opportunities, and so you should definitely keep an eye out. You need to have a collaboration between the HBCU and another tier 1 institution, and so get those collaborations ready. And I think there are regular calls for it. Dr. Budani?
Yeah, I think Dr. Vail, you have actually explained it very well. The best, my recommendation is to contact Ms. Evelyn Kent's office, because they would know what is there available for such collaborations. I think this particular program, this call is now closed, but I'm sure they are starting something new.
Okay. Thank you so much for that. So the next question comes from Richard, and Richard is directing this question to you, Dr. Vail. Do you have a schematic showing the details of your spectrometer, optics bench. Most importantly, how the sample is placed and measured for your configurations. And he says that they are developing an NRI/MIR waveguides for laser components. Can you
Yeah, Tech.
yeah.
So we have a number of different setups. So we have the XPS. We also have a number of photoluminescence setups for photoluminescence mapping. We've been using that a lot for like excitons and things in 2D materials. The one that I showed here was second harmonic generation. We also have some optoelectronic setups. So there's a lot of different setups. We have a few really talented people in optics on our team that are really interested in these kinds of materials, the 2D materials and so on. You ask about infrared. We have a lot of explorations these days into polarimetry. So we're talking a lot about like SHG and stuff like that, second harmonic generation, but also like a circularly polarized photogalvanic effect, and other kinds of effects where light comes in with a certain known orientation, and then either reflects or transmits. So not so much waveguide stuff. But I hear where you're coming from. It's hard for me to give a direct answer to this. I don't do optics myself. And we have a lot of different setups. So I'm happy to maybe try to help connect you with people, or talk more. I don't know if are we sharing, Crystal? Are we sharing emails with it? That they'll have our emails and stuff,
Yes,
right?
it certainly
Okay,
will.
cool. Yeah, so you can send me an email and I'll try to connect you with people that will know better about what kinds of optic setups we have at ARL and what might kind of work with what you're working on.
Wonderful. Thank you for that. I believe we have time for one other question. And this is for all of the doctors. The question is, Hong would like to know that he has a team of 5 collaborators, and he wants to know which DoD HBCU-MI program will best fit the size of his team.
Yeah, so a lot of the HBCU-MI programs that I know are for students. This one is kind of the big one for centers, establishing a center. And as Dr. Badani said, you should probably contact Miss Evelyn Kent with a team that size. I'm sure she's interested and will help you connect with an opportunity.
Okay. Thank you so much. So that is going to wrap up our Q&A session today. And just as we just stated, you'll see the contact information for Dr. Vale, Dr. Badani, and Dr. Tone, and also others on your screen. Feel free to take a photo or screenshot so that you can follow up with additional questions or discussions after the webinar has ended. Once again, we'd like to extend our sincerest gratitude to Dr. Owen Vale from the Army Research Laboratory, Adelphi Laboratory Center, Dr. Ramesh Budani from Morgan State University, and Dr. Susanna Tone from Johns Hopkins University for sharing their expertise. And of course, we definitely thank you, the attendees, for joining us today to explore how Army academic partnerships are driving innovation and opportunity. This concludes our presentation, and we do hope that you have a great rest of your day. And goodbye.